This image is utterly captivating. What is it about this view that pulls us in so deeply? This is Proxima Centauri. For over a century since its discovery, this star has enchanted astronomers across the globe. It sits so achingly close, yet it would still take lifetimes to ever set foot there. Invisible to the naked eye, yet it's the closest star to our own solar system. At one point, it held the record for being the dimmest star humanity had ever found, while paradoxically burning with the greatest activity. As if those contradictions weren't enough to draw us in, scientists have recently discovered a potentially Earth-like planet orbiting it, sparking wild debates about interstellar colonization that feature names like Mark Zuckerberg, Elon Musk, and Stephen Hawking. It almost feels as if Proxima Centauri is deliberately teasing us, playing with our insatiable curiosity about the mysteries that lie beyond. If you're anything like me, you simply can't wait to soak up every last secret about this enigmatic star. Join me today as we embark on a whirlwind journey through the enchanting Alpha Centauri star system. We'll sweep from the dazzling binary duo of Alpha Centauri AB to the mysterious depths of Proxima Centauri, unraveling secrets about its recently discovered planets, a hotly debated potential discovery, and what future flyby missions might unveil. Imagine leaving Earth behind and traversing just over 4 light-years to reach the closest known stars to our solar system. I say stars because Alpha Centauri isn't just a single point of light. It's a breathtaking triple-star system. Collectively known as Alpha Centauri, these cosmic neighbors are Rigil Kentaurus, Alpha Centauri A, Ptolemy, Alpha Centauri B, and Proxima Centauri. Together, Rigil Kentaurus and Ptolemy create the dynamic binary known as Alpha Centauri AB, located 4.37 light-years away from Earth. Both are sun-like stars, forever dancing around a common center every 79.76 years. And if you find yourself south of the 40th parallel, you can spot them shining at night. Though to the naked eye, they blend together as a single gleaming star, the third brightest in the sky, trailing only Sirius and Canopus. The binary Alpha Centauri system was first discovered back in 1689, but it would take more than 2 centuries before a hidden third star finally revealed itself. Fate intervened in 1915, shining on a Scottish astronomer named Robert Innes. At that time, Innes was serving as director of the Union Observatory in Johannesburg, South Africa. While meticulously comparing photographic plates using a blink comparator, he noticed something extraordinary. A faint star had shifted its position over the 5 years between exposures. Remarkably, this tiny star's movement closely matched that of the Alpha Centauri binary he'd been studying. Innes began to wonder if this mysterious new star might belong to the same family. Delving deeper into his research, he ultimately concluded that this faint companion was, in fact, even closer to the Sun than its 2 bright siblings. A revelation that his fellow astronomers quickly confirmed. If you believe in the power of science and the spirit of discovery, leave your thoughts below. Share this video with your friends, and don't forget to subscribe so you'll be part of our next cosmic adventure. Paradoxically, Proxima Centauri became both the closest and dimmest known star to Earth at the time. Yet, the cosmic surprises didn't stop there. In 1951, American astronomer Harlow Shapley made a groundbreaking discovery. Proxima Centauri is a flare star. Not only that, but it held the title of the most active flare star known back then. For more than 70 years now, Proxima Centauri has been at the center of scientific fascination. Its allure as hot a topic as its literal fiery nature. With the recent discovery of an Earth-like exoplanet orbiting it, I'm certain the world's curiosity is only set to grow. But let's not jump too far ahead. Before we pile all our hopes onto this little star, let's get to know it better. Sitting 4.24 light-years away, Proxima Centauri is just a touch closer to us than Alpha Centauri B. It's a main-sequence red dwarf star with an estimated mass of only 12.2% and a diameter just 15% that of our Sun. And yet, despite its petite size, Proxima Centauri is about 40 times more dense than our Sun. Its low mass means the interior is fully convective, stirring up a powerful magnetic field. This leads to sudden, dramatic releases of magnetic energy in the form of spectacular flares. As a result, Proxima Centauri is subject to sudden, dramatic swings in brightness and energy output. On May 6, 2019, astronomers witnessed a record-breaking flare event, the brightest ever recorded on Proxima Centauri. These explosive flares unleash radiation spanning the entire electromagnetic spectrum, even reaching into powerful X-rays. To put its solar activity in perspective, Proxima Centauri's baseline X-ray luminosity is nearly equal to that of our Sun, a star that's much larger and much hotter. During a flare, this level can soar up to 100 times higher. Not only are these flare events more intense than those on our Sun, they also happen far more frequently. It's estimated that a staggering 88% of Proxima Centauri's surface is active at any moment, a figure that dwarfs our Sun's activity, even at the height of its solar cycle. But before you start imagining Proxima Centauri as an uncontrollable ball of cosmic fury, remember, we're comparing two very different beasts. Our Sun isn't a red dwarf. In fact, among its red dwarf peers, Proxima Centauri is actually considered to be on the quieter, more subdued end of the spectrum. Unlike our Sun, which scientists believe will only consume about 10% of its hydrogen before it fades away, Proxima Centauri is expected to use up nearly all of its fuel before leaving the main sequence in an unfathomable 4 trillion years. By that distant epoch, Earth, our Sun, and everything we know in the solar system will be little more than cosmic memory. Alpha Centauri AB sits a staggering 0.13 light-years, or 2 trillion kilometers, away from Proxima Centauri. You might be asking yourself, if Proxima Centauri is so far from its stellar siblings, how can it still be part of the same system? The answer lies in the data. Proxima Centauri is gravitationally bound to the Alpha Centauri AB binary, making it an official member of this celestial family, with an orbital period of about 550,000 years. How Proxima Centauri ended up in this peculiar orbit remains an open question, but astronomers have two leading theories. 1. Proxima Centauri was born with the Alpha Centauri system, sharing the same stellar nursery and elemental makeup. Or 2. Proxima Centauri was captured by the gravitational pull of the binary stars during a close cosmic encounter, tumbling into a highly eccentric orbit, later steadied by the gentle tides of the galaxy and further interactions with wandering stars. Regardless of how Proxima Centauri became part of this cosmic trio, current calculations suggest that in about 3.5 billion years, it will break free. As Alpha Centauri AB evolves and gradually loses mass over its lifetime, Proxima Centauri will drift away, severing its gravitational bond to the system. Even the Alpha Centauri AB binary itself is destined to part ways in roughly 12 billion years, transforming into two white dwarfs, each forging a lonely, divergent path through the cosmos. As our closest stellar neighbors, we've learned a great deal about Alpha Centauri AB. But a deep dive into this fascinating binary system is a story for another video. For now, the spotlight is firmly fixed on Proxima Centauri. The search for exoplanets around Proxima Centauri has been underway since the mid-2000s. But for years, results were scarce, and hopes often dimmed. Still, astronomers never gave up. After all, Proxima Centauri isn't just our nearest neighbor, it's also a red dwarf, and an estimated 20 to 40% of such stars have planets orbiting within their habitable zones. That patience finally paid off. Observations at the European Southern Observatory in Chile detected strange anomalies in Proxima Centauri that couldn't be chalked up to flares or other solar phenomena. The data suggested something intriguing. A planet might be orbiting the star. In January 2016, the Pale Red Dot campaign was launched. A coordinated global effort uniting multidisciplinary scientists and ground-based telescopes to uncover whether this mysterious planet truly existed. Then, in August of that same year, came the electrifying announcement: the discovery of exoplanet Proxima Centauri B. This distant world is at least 1.07 times larger than Earth, and sits a mere 20th of the distance from Proxima Centauri that Earth is from our own sun. Proxima B whips around its star in just 11.2 Earth days. And though this exoplanet sits firmly within Proxima Centauri's habitable zone, that's not the same as saying it could support life. There's so much more to habitability than just the presence of liquid water. For starters, the fierce solar activity from Proxima Centauri would bombard Proxima B with anywhere from 10 to 60 times the UV and X-ray radiation we experience on Earth. We'd need sunscreen with SPF 3000 just to survive the trip. Another crucial question is whether an atmosphere could even endure such a relentless assault. As we understand it, atmospheres are absolutely vital. They maintain surface pressure suitable for liquid water, shield planets from deadly space weather, and regulate climate. The harsh radiation Proxima B endures could easily strip away its atmosphere's key components over time. And, frustratingly, aside from its distance to its star and its orbital period, we know precious little about Proxima B. Don't forget to hit like, share, and subscribe to never miss another incredible story from the universe. Let's keep this passion for discovery alive, together. It's highly unlikely that Proxima B has any moons, since their orbits would be unstable over long timescales. More likely, the planet itself is tidally locked to its star, forever showing just one face to Proxima Centauri. Proxima B almost certainly developed under radically different conditions from those on Earth. If it formed at its current distance from the star, its evolution would have been much more rapid, with more intense impacts and far less water. However, the planet's origin story is still debated. Some scientists believe the protoplanetary disk around Proxima Centauri simply didn't have enough material for such a world to form so close in. The more likely scenario is that Proxima B began life farther from its star and slowly drifted inward to settle into its present orbit. As for what the planet's surface actually looks like, that's anyone's guess. Theories span a frozen world locked in perpetual ice, a planet-wide ocean like Earth, though unlikely if it's truly tidally locked, a barren, waterless landscape, or even a world with a subsurface ocean, not unlike Jupiter's icy moon Europa. In short, no clue. We haven't directly imaged this planet yet, so the truth will have to wait until our first close flyby. A mission that some tech titans are already setting their sights on. If it does happen, I have a feeling it'll be every bit as earth-shattering as the iconic Voyager flybys of the 70s and 80s. But more on that later. 6 years after the discovery of Proxima B, headlines around the world lit up with the news of Proxima D. The first hints of this planet surfaced in 2020, when scientists detected a faint 5.15-day signal in the radial velocity data during efforts to pin down Proxima B's mass. After more data collection and rigorous analysis, scientists finally announced the discovery of Proxima D in February 2022. So far, here's what we know. Proxima D is a sub-Earth planet, at least 25% the mass of our own world, orbiting its star every 5.1 days. Sitting just 4.3 million kilometers from Proxima Centauri, it hugs its parent star so closely that its equilibrium temperature would soar to a scorching 87 degrees Celsius, far too hot for habitability. It's probably tidally locked as well, relentlessly bombarded by radiation, making any hope of life there slim to none. But this little world holds promise in a very different way. Proxima D is the lightest planet ever detected using the radial velocity method. Since it's too distant for telescopes to see directly, astronomers rely on a subtle wobble in the host star's movement, a clue to a planet's presence. The more massive the planet, the stronger the wobble. But for Proxima D, the signal was barely detectable. Catching this faint wobble and proving it belongs to a planet is a true technological feat. Yet, astronomy is rarely simple. Where there's discovery, there's also doubt. This tension is clear with Proxima C, a controversial exoplanet. First detected in 2019 via radial velocity and seemingly confirmed by Hubble in 2020, its existence was challenged in 2022. Critics argued the signal could have come from small, overlooked errors in the data, essentially a miscalibration. Unlike Proxima D, which hugs its star, the supposed Proxima C orbits far away, with an estimated period of 1,928 days. Its status remains uncertain, highlighting both the promise and limits of astronomical discovery. There is no similar example of a wobble detection of a planet with such a low amplitude at such a long period. That doesn't necessarily mean it's wrong, but it is going to require some confirmation from additional observations, says Paul Robertson, astronomer at University of California, Irvine. If Proxima C does exist, it will take a bit more data to convince reluctant skeptics. If it does not exist, it remains unclear why the Hubble astrometric data was able to corroborate and confirm a planetary signature. I guess we'll just have to wait and see what future studies find. With the recent discovery of Proxima B and how relatively close Proxima Centauri is to us, it is a perfect candidate for a future flyby. If you believe in the power of science and the spirit of discovery, leave your thoughts below, share this video with your friends, and don't forget to subscribe so you'll be part of our next cosmic adventure. However, reaching our neighboring star system would take thousands of years with conventional propulsion technologies. Newer techniques, like solar sails or nuclear propulsion, could make such a journey possible within a single human lifetime. Bold visions like these sparked the creation of Project Breakthrough Starshot, an ambitious initiative led by investor and physicist Yuri Milner, the late Stephen Hawking, and Mark Zuckerberg. Their goal: to reach the Alpha Centauri system in the first half of the 21st century. The plan is to launch a flyby mission using microprobes weighing just a few grams, blasting through space at 15 to 20% the speed of light. They believe this could happen as soon as 2036. If all goes as planned, the probes would reach Alpha Centauri in just 20 years, with the first precious data arriving on Earth 4 years after that. After this initial flyby, the tiny explorers could press on to the exoplanets, gathering atmospheric data, much like the legendary Voyager missions did in the outer reaches of our solar system decades ago. The team is pinning all their hopes on the as-yet undeveloped star chip, a microelectronic wafer weighing just a gram, packed with cameras, photon thrusters, a power supply, navigation, and communication gear. In essence, it's a complete space probe, miniaturized to a breathtaking scale. Their vision is fueled by Moore's law, the principle that computer speed and capacity double roughly every 2 years. As bold and ambitious as this plan sounds, it's not without major challenges. The proposal involves using 100 gigawatts of ground-based lasers to push these microprobes into the cosmos. That's the combined output of 100 massive nuclear power plants, all focused onto a target only centimeters wide. On top of that, every component of these tiny explorers must be engineered to survive wild acceleration, freezing temperatures, vacuum, and collisions with interstellar dust. With this in mind, perhaps the project should really be called Project Breakthrough Longshot. After all, if history has taught us anything, it's that missions faced with impossible odds and punishing challenges can become humanity's greatest triumphs. Maybe Proxima Centauri will be the next to make history. Here's hoping we'll be around to see it. Have you ever wondered why only some materials are magnetic? Magnetism operates at the level of atoms and electrons. Each moving electron creates its own magnetic field. If these fields aren't aligned, they cancel each other out, and the object has no net magnetism. Looking back on humanity's quest to unlock the mysteries of Proxima Centauri, we can't help but marvel at our endless curiosity, bold vision, and determination to reach beyond what seems possible. From tracing faint stellar wobbles to dreaming of tiny probes racing across the cosmic ocean, every step is proof of the power of human ingenuity and hope. It may be decades, or even centuries, before we set foot on a planet orbiting Proxima Centauri. But the journey has already begun. Right here. Right now. Who knows? Maybe you, or someone in the next generation, will one day receive the very first signal from a distant new world. Whatever the outcome, each effort reminds us. As long as we keep looking up and asking questions, humanity's future will always shine bright with possibility. So keep that sense of wonder alive, because the next great discovery may be waiting just beyond the horizon. If you believe in the power of science and the spirit of discovery, leave your thoughts below. Share this video with your friends. And don't forget to subscribe, so you'll be part of our next cosmic adventure.